Acids and bases. Answer the following based off of the equation below. Label the Bronsted-Lowry acid base, conjugate acid, and conjugate base. Okay, so Bronsted-Lowry acid is that the acid is donating a proton, and base accepts proton. Well, going from NH4 plus to NH3, this NH4 plus donated its hydrogen, so this is my acid. And if you look at OH to H2O, that gained a proton, so that is my base. Since ammonium ion went to NH3, that is my conjugate base. It took away the hydrogen, it gave it away, and water is my conjugate acid. How many grams of OH are needed to titrate 50 milliliters of 0.1 molar ammonia? So a titration is when you add acid and base together and wait until it neutralizes, forms water. You usually have an indicator that tests the pH so that you can see where the change is when they have reached equilibrium, they've reached neutral zones, water. Or you can use an equation. So if I wanted to figure out exactly how much volume, I know the stoichiometric coefficient, and it's just like all the other questions we've done before. So I know I have 50 milliliters. I know molarity is mole over liter. And if I want grams of OH, I'm going from one compound to another, I must use mole ratio. So my first step is to go to moles. I take my 50 milliliters and convert. Then use my molarity. And now go to moles of OH. And before I do that, I have to make sure I'm balanced. Let's see, 1 nitrogen, I have 5 hydrogens on both sides, 1 oxygen. So it's a 1-to-1 ratio, so 1 mole OH over 1 mole ammonia. Then I can use my mass to get grams. Double check, milliliters go away, liters cancel, moles of NH3 cancel, moles OH cancel, and I'm left with 0.085 grams of hydroxide. So always thinking that Arrhenius acid base, Arrhenius acid is that an acid makes a hydrogen ion when it's dissolved in water, and a base makes hydroxide when it's dissolved in water. When thinking of Bronsted-Lowry acid base, a Bronsted-Lowry acid donates a proton, and a Bronsted-Lowry base accepts a proton. Now, the conjugates are just the pairs of the acids and the base. If you look at ammonia, it lost that proton from ammonium ion. It's its conjugate base. Water accepted the proton, so it's the conjugate acid. Therefore, they have the conjugate acid-base pair relationships. Then when you're doing a titration, you're just looking at concentration and volume, just like we've done before, using the mole ratio. We have molarity and volume. You take your volume and get moles. Well, if I wanted the moles of that particular substance, I would be finished. But because I wanted a different substance, you always go back to mole ratio. So you always look back at your equation and make sure it's balanced. And then just solve for the unit you want, whether that's volume from concentration, atoms, particles, grams, etc. You use whatever conversion factor to get you to